Hello, testing. Yes, we are back. Sorry for the mini technical issue. My goal for today is to make sure there are as little technical issues as possible. I don't know if we'll get there or not, but that is my goal for today. Yes, I have made a lot of changes to make sure that hopefully my internet will stay connected during the stream. So yeah, let's see how it goes. All right. So let us do what we're here to do, which is we are right now hopefully live in where? Yep, we're good. And it's green and that's also good. Awesome. And I can just go to my nice. For some reason I was expecting this to also have been messed up. And I did keep my I kept my costume. It's not really a costume. It's just I have a cat on my shoulder. Yeah. I wanted to keep the Halloween theme until the end of this stream train, which I could talk about this as streamathon thing. Let's talk about that. So there is this streamathon that I think it's made by two people. I should know better. But even right now, hold up. Let's look at the screen. There we go. So I know Fur's name is on it, but I think also only Ken Trop is also one of the organizers. And today's the last day, and I'm here. And yeah, I mean, they're already live now. Tafida playing a horror game, and my version of horror is math. Boo. So yeah, I asked them if it's okay if I continue doing my normal streams, and this is a normal stream for me, and they said it's cool. So last stream, which was 3 days ago, I think, everything was very bad, and I didn't even try to save the VOD, so I'm gonna try and make it up. Oh, these are my badges. Can I see my own badges? Interesting. Why do I not know the number of the badges I have? Because like, you see some of them are 0, so they're not exactly my badges, but I have 7 of this one and 1 of this one. Good to know. 8 total badges, neato, exactly. Alright, so we have we finished unit 1, and for unit 2 I did start the first one. I watched the first video. It is showing a scale, and I'm not gonna play it fully, but we go back to the beginning.
All right, now we have
we try to solve this y. We have 1 kilograms on this side, 7 on this side, I think. 3 unknown y's and 1 known y on that side. So if I take out my pen, let's take out the pen, try to write. To write this equation, we would say 3y. Is it 3y or is it 3 plus y equals 7y? No. Wait, I forgot. I know it had. Oh, there we go. It is 1 to 3 y's, but also plus the 3 known quantity. There we go. Now we have 7 plus 1y. And what we do about this is that we take away the number, so we take away 3 from here, which means we have to take away 3 from here. 1, 2, 3. We have 4 numbers left, so it would be like 4 plus y equals 3y. For that, 1, 2, 3, 4. Let me use my brain. Just a second, my brain is lost. Oh, we take this y, like we can just take 1y away from here, and then take 1y away from here, and we have 2 y's left, equals 4, meaning if we half both sides, divide them by 2, divide by 2, this 2 will go away, and this becomes 1, 2, so y itself is 2, basically. And that was the explanation from a few days ago. He explains it better, obviously, but here I am trying to make up for it so that the VOD stays. It's easier to bring number... Hi, by the way. It's the easier way is to bring number to one side and variable to one side. That is a really good note, to make sure that all variables are on one side and the numbers are on one side, so that when you keep chipping away at it, you get you get to the results easier. Thank you. That's a good note. Also, hi. Hello. So yes, so my plan was to do the practice problem, and if needed I can go back, but I did think that those are going to be rather simple, hopefully, but if not, I don't have any issues going back. So let's practice. And do I remember the result of this one? I think it was 10, but hey, let's continue. So we have 9. Oh right, it's not pen. Now it's pen time. We have a 9e plus 4 equals minus 5e plus 14, and then a plus 13e. So right away we have a negative number and a positive number. I can just take this much out of here. So I'm just going to do that because it looks the easiest for me. And that would look like, take 5 away from 13, 3 from that side, 2 from that side. We have 8 left, 8e plus 14. And then on this side, nothing's changed because we just did some math here. So we still have 9e plus 4. And if we take your note, we can now move the e's around. And I did say that in the last stream. I think my teacher was saying, like, this is the way she taught us. She was like, if you move something from one side of the equation to the other, its sign will change. And that's how I do it. Instead of saying, I'm going to take 8e away from this side and 8e away from that side. In my mind, I say, I take this from here to there. And if that's not how you learned, I'm sorry. But yeah. Oh yeah, hi. Okay, ReadyBot is now saying how cool I am. Thank you, ReadyBot. I also think I'm really cool. So we have the 9e. Now we have negative 8e. And I'm not going to move the numbers yet because that would be like too much change. So let's just keep it equals 14. So on this side, now... No, please don't solve it for me. Thank you. I appreciate that. I'm solving it slowly on purpose. I really appreciate you trying to help me. And no, don't say sorry because I already solved it in the last stream. It's okay. I don't mind. I'm being slow on purpose. So here, take 8 out of 9. We just have 1e left. And then we have the 4 equals 14. And now 4 is going to make the journey across the equal sign. Like that. Which will be e equals 14 minus 4. And then that is 10. And that is the final answer. 10. Ta-da! We got there together. Yes, you could probably do the movements quicker, but this is how I would like to do it. And 10. Let's test if this is actually the correct answer. Yes, nice. Okay, so now you can solve it, and then when I also reach the end, you can put it in the chat and tell me if we reach the same conclusion, because unsurprisingly, I do make a lot of mistakes. So it would be cool if you also try to solve it at the same time. For this one, let's do 7b minus 15 equals 5b minus 3. So this would be like, oh, this is a negative. Interesting. Both of them are negatives. Okay, so I'm gonna move this 5b to the other side, and it will become negative. So it's going to be 7b minus 5b minus 15 equals minus 3, or negative 3. Here we have 2b's left, and if I take this number while we're doing this to the other side, we will have so this is going to be positive because it's already negative, so I'm going to put it on this side. 15 minus 3, and if you take away 3 from 15, it's 12, and then this side is 2b. Now we need to divide both sides by 2, so let's do that. And now b is 6. B is 6. Did we reach the same conclusion? Let me know. And I'm gonna put it in the solution part and test if we reach the same conclusion or not. Yay! All right. I will definitely ask. Oh, nice! We did reach the same conclusion. And now this one. Okay. For this one, we have 6c plus 14 equals negative 5c plus 4 plus 9c. We have the same situation of like a negative and a positive on the same side. So if I take 5c out of 9c, we will have 4c. So let's do that. We have 4c plus 4. And on this side, nothing has changed. We still have the 6c plus 14. Oh my god, is this... Are we... Oh, the answer is 5, right? I thought it's the same as the E one, but it's not. So I'm gonna move this 4c to the other side, and no, this becomes negative. If I take this to the other side, it's going to be negative. Same, both of them will be negative. So let's try that. We have the 6c minus 4c equals, now we have the 4 that was here already, and then we have the negative 14. For this side we have a 2c left, and for that side we have a negative 10. If we divide both by 2, we will have c equals negative 5. Oh, nice! I wasn't looking at chat. We reached the same conclusion. Nice. So let's say it is negative 5. Nice. Final question of this practice. We have 4b plus 5 equals 1 plus 5b. And if we do the moving, so I'm gonna take the smaller one to the other side because I prefer taking smaller out of bigger things. Same with this one to that side. So if I rewrite it, it's going to be 5 minus 1 equals 5b minus 4b, and On this side, what? Oh my god. Why did I write 4 here? Whoa. This is a 5, people. This is a 5. The 5 is positive. The 4 is negative. So we have 1b on this side. And here we have a 4. And b is 4. Did we reach the same conclusion? Even though it looks like 4 is b, you can read it as b is 4. Alright, let's test it. Let's hope it's not. Yay, we did it. And that's a music that comes up when I guess you did something good. So we're done with this part. Nice. Yay. So we got a purple, which means we got that correctly. Next up. Yes. Sure. These are very simple equations. Yes. And I'm here to just enjoy math. I hope you're also enjoying it. Yeah, so we have one more practice here and then 2 videos. I'm going to play the video using the distributive property to solve a multi-step equation. Cool. The reason I'm going to play this is because when I play it, I can drink coffee. But if it's too simple, we may skip it. For the time being, I'm going to play it so that I can drink some coffee. Let's do this.
We have the equation 3/4 x plus 2 is equal to 3/8 x minus 4. Now, we could just, right from the get-go, solve this the way we solved everything else. Group the x terms, maybe on the left-hand side. Group the constant terms on the right-hand side.
Yes, giving us same advice about grouping constants, which are numbers, and then variables, which are the x's and stuff on other sides. I unmuted myself to say, I don't love getting these in my equations, but hey, you get them sometimes, and you have to deal with them. That's it. That's all I wanted to say. Okay.
But adding and subtracting fractions are messy. So what I'm going to do right from the start of this video is to multiply both sides of this equation by some number so I can get rid of the fractions. And the best number to do it by, what number is the smallest number that if I multiply both of these fractions by it, they won't be
2.
fractions anymore. They'll be whole numbers.
Wait.
And that smallest number is going to be 8.
Oh. Huh? Smallest number would be 8? Oh yeah, good job. You know way better than me. If we do it, this one goes away, but here. Oh, now my brain works. Okay. I remember. See? I've literally forgotten everything.
That smallest number is going to be 8. I'm going to multiply 8 times both sides of this equation. And you say, hey, Sal, how did you get 8? And I got 8 because I said, well, what's the least common multiple of 4 and 8? Well, the smallest number that is divisible by both 4 and 8 is 8. So when you multiply by 8, it's going to get rid of the fractions. And see, let's see what happens. So 8 times 3/4, that's the same thing as 8 times 3 over 4. Let me do it on the side over here. That's the same thing as 8 times 3 over 4, which is equal to 8 divided by 4 is just 2. So it's 2 times 3, which is 6. So the left-hand side becomes 8 times 3/4 x is 6x. And then 8 times 2 is 16. You have to remember, when you multiply both sides or a side of an equation by a number, you multiply every term by that number. So you have to distribute the 8. So the left-hand side is 6x plus 16 is going to be equal to 8 times 3/8. That's pretty easy. The 8's cancel out, and you're just left with 3x. And then 8 times -4 is -32. And now we've cleaned up the equation a good bit. Now the next thing, let's try to get all the x terms on the left-hand side and all the constant terms on the right. So let's get rid of this 3x from the right. Let's subtract 3x from both sides to do it. That's the best way I can think of getting the 3x, getting rid of the 3x from the right. The left-hand side of this equation, 6x minus 3x is 3x. 6 minus 3 is 3. And then you have a plus 16 is equal to 3x minus 3x, that's the whole point of subtracting 3x is so that they cancel out. So those guys cancel out, and we're just left with a negative 32. Negative 32. Now, let's get rid of the 16 from the left-hand side. So to get rid of it, we're going to subtract 16 from both sides of this equation. Subtract 16 from both sides. The left-hand side of the equation just becomes, you have this 3x here. These 16s cancel out. You don't have to write anything. Is equal to negative 32 minus 16 is negative 48.
Oh.
So we have 3x is equal to negative 48. To
Mm.
isolate the x, we can just divide both sides of this equation by 3.
Mm-hmm.
So let's divide both sides of that equation by 3. The left-hand side of the equation, 3x divided by 3 is just an x. That was the whole point behind dividing both sides by 3. And the right-hand side, negative 48 divided by 3 is negative 16.
Nice.
Negative 16. And we are done. X equals negative 16 is our solution. So let's make sure that this actually works by substituting to the original equation up here. And the original equation didn't have those 8's out front. So let's substitute to
Oh.
the original equation. We
I
get
actually normally never do that, substituting to see if it correctly works.
3 fourths, 3 over 4
Mm-hmm.
times negative 16 times
Mm-hmm.
negative 16 plus 2 plus 2 needs to be equal to 3/8 times negative 16 times negative 16 minus 4. Minus 4. So 3 fourths of 16 is 12. And you could think of it this way. What's 16 divided by 4?
Mm-hmm.
It is 4. And then multiply
Times
that by
3.
3.
Mm-hmm.
That's 12. It's multiplying fraction. So this is going to be a negative 12. So we get negative 12 plus 2 on the left-hand side.
Mm-hmm.
Negative 12 plus 2 is negative 10. So the left-hand side's a negative 10. Let's see what the right-hand side is. We have 3/8 times negative 16. If you divide negative 16 by 8, you get negative 2 times 3 is a negative 6. So it's a negative 6 minus 4. Negative 6 minus 4 is negative
Negative
10.
10.
So when x is equal to negative 16, it does satisfy the original equation. Both sides of the equation become negative 10. And we are done.
Nice. So we have an exercise, which is probably what we about fractions. Ooh, even decimal points. I don't love them, but hey, let's try. Okay. If anyone is like annoyed in the chat because I do things slowly, it's okay. I really don't mind if you do something else. Because I would apologize for. Oh, wow. I wrote 15. It's 16.5. Good job. I really don't want you to like waste your energy and be annoyed by my slowness. 10C. So. Okay, actually this is pretty easy for me. I mean, not easy for me, but like looks easy. We just take this out of here, and then we take this. Oh, sorry. What did I do? Oh no, why is my pen still writing? Stop writing. Okay. Out of here. Yes. Hi, children. Let me know if you are bothered by my style. So we have the 16. And the reason why I'm taking this to this side is because I want to take the small one out of the big one. I don't like negatives. Why do I not like negatives? That feels like a bias. Oh, sorry. There's a bias there. 5 and then minus 13.5, which this just solves our fraction problem, equals 10c minus 5c. And now on this side we have a 5c. On that side, what I see is like fraction goes away. 3 minus 2. No, 3. 6 take away 3, 3. And that's it. Right? So is the result like is the result wait. Huh? Oh, right. I need to divide both sides by 5. Oh, right. Is that the result? C equals 3/5? And if what do I do here? I'm not gonna do anything, and I'm just gonna thank you. Thank you, chat, for so if I say 3/5, will it accept it? Is my question. It did. Good. Okay. All right. Now, next question. You know what? Oh, hi. Why is there a 0? Oh, got it. Thank you. Yes, 0.6, because then the denominator would be 10. Then that's actually, thank you. Oh, ads already? What? No, oopsie. Oh, I don't see it because I don't see Twitch chat. Oh, yes, ads. Oh, wow. That's a lot of chat. Yes. To use my brain, thank you, coffee, and also good morning, hi. Yeah, I can just have the denominator be 10 so that I can show it as a decimal point, because that was the thing that stopped my brain. I was like, can I give it fractions or does it take decimal points? Cool. And I don't know if you heard any of that. Checking. We are good. Nice. Let me know when I can see that ad will be over in 10 seconds, but still let me know when ads will be over. I don't think everybody gets the same length of ads. Community should be back. Hi, community. What's up? Over. Yes. I see the time. What is the thing? A timer that goes down? Countdown. I see the countdown. Yes. We're back. Thank you for, I forgot how to make decimals out of fractions, and thank you for that in the chat. I was saying, I know I solve it slowly, but you guys can. By the way, did the bot need a response? I don't know. It's too early. I know my slot is in 20 minutes, so I don't want to say I'm ready half an hour before. I can say that 10 minutes before or 5 minutes before, you know? I feel like it's, I'm not writing. Am I writing now? Nope, still not writing. And now I'm writing. Yeah. I will do that in a bit. Now, 11/2 equals another 2D. Oh no, that's different. I was like, I need to do the common denominator thingy. I guess, no, I'm not, yes? No? Okay. Have patience, please. But does it make sense if I take this away like that and then have this be a 3 and have this be a 2? And I just saw that answer in the chat. I could probably submit this, but I need to get there first. So I'm going to try that. If that's wrong, forgive me. I'm here to learn. So 3D minus 11. Let's see if I get to the same answer as you. And then D minus 13. If that is wrong, I'm going to be embarrassed. You go to that side, and you go to this side. 3D minus 1D equals minus or negative 13 plus 11. And then this one would be 2D, and this one would be take 11 out of 2. This has to be wrong because this is different from your answer. Because my answer is like D is 1. Huh? Oh, wait. Oh, minus. Yeah. Okay, that's a minus. But mine is -1. Yours is divided by 2. Interesting. Interesting. What do I do now? Was that all wrong? Should I try again? I have zero faith in myself. Let's try again. Yep, there we go. So -11. Wait, actually, I can try and solve it. That's a interesting idea for me. From me. So I can do both. Nope, was correct, I think. Cool. I'm gonna solve it with the -1 and then solve it with the -1/4 and see which one works here. So we have the -1, and again, I really think it's going to be wrong. Here we go. 11/2 equals 2 -1s, 13/2. That's just a -6. And then we have the 11/2. I mean, I should still be able to kill this and this be a 3. That's a -2. And then 13/2. Kill this. We have 2. What is math? I have a minus here, and it stays because it becomes a -1. It has to be a -1. And then a -13. And on that side, we have -3, -11. Oh, this is definitely wrong. Because this is now 13 and correct, but here 1 is left. Oh. And now we try to solve it again. Thank you for your patience is all I gotta say. 2d -13/2. I guess I'm just gonna have to do the thing where you say 2 and then 2. So this becomes 12d -22. No, that's not how it works. No. If I say 2 times here, this 2 will kill it, so we just have the 11 equals 4d -13. Now this should work. Hopefully. We'll get there. And then I'm just going to take you on that side and take you on this side. So we have 12d -4 equals -13 plus 11. And then we have, you are overcomplicating it. Yes, welcome to my brain. This is a D. So now here we have 8D, and on this side we have my -2. Then now I just reached your solution, which is divide, well, just take this there, -2, 8, and it becomes -1/4. Thank you. We got there. And the other solution was wrong. Cool. -1/4. Here we go. Yay. I do want to do every step. I don't want to skip steps because I know I will make mistakes. And that's what I'm here for. To remind myself stuff, 0.5s plus 1 equals 7 plus 4.5s. I'm happy that the 0.5s will go away. So we're just gonna take you over there, and sadly I'm gonna have to take you over there, as much as I would not like to do that. So we have the 1 minus 7 on this side, and the 4.5s minus 0.5s on that side. So here we have a 4s. And on this side, we have a minus 6. And if we divide both by 4 or 2, I'm going to do 2. My brain goes that this far. We get a minus 3 and a 2s. And then the final solution should be like that. Did we get there? S is a... What is this? What is this thing here? It's supposed to be an S. Cool. 3, 2... What's a 3, 2? I'm not going to do the thing where you can say... Nope, I'm not going to try it. Okay. Negative 3 2s. You could probably simplify this more. Sometimes I also struggle with stuff like this because I make simple mistakes. Thank you. Yeah, I guess. Yeah. I know this can be simplified more, but I don't have it in me. One last question. Thank you for your patience. Okay. I mean, like, you guys have free will. You really don't need to be here. You can be wherever you want to be. Is the thing that makes me feel better. Hey, what is that? Try again. 8 divided by 3, C. That can be also the simplified, but again, we're not there. I'm not there. 2/3 C minus 12. All right. So I probably should just do the thing where we say 3 and 3. So when we do that, could be 1 exactly. Yes. I was thinking the same thing, but I was also like, but is that correct? Because I know there's a 2 in the 3, so if I take it out and put it as the big number, then 1 will remain. So 1.5. Yes. I also, I that's what I thought. Hi. Oh, hi, Momo. Hi. You changed your icon, right? Because it gave me a second. I was like, do I know this icon? So we kill this with fire, but then have to do this, and then kill this with fire, and then have to do this, and the resulting thingy would be 8 C's minus 6 equals, yes, you did, nice. I can brain. That's correct because 2. Okay. The 1 is like 2 2s. Nice. Thank you, Coffee. Thank you. We went from talking about transformer language models to saying 1 is 2/2, and I am happy about that. Let's just make life simple for our brains. But again, you guys have free will. You don't need to be here. What's 3 times 12? I know 2 times. Hello, famished. Edith. Hi, first time chatter. What's up? So 2 12s is, you know what? I'm just gonna do this. Oh, yeah, brain. Stop writing things I don't mean. 12 and a 3. That's a 6 and that's a 3. There we go. We got there. 36. So I'm gonna take this little guy to here and this U to there. Let's do that. 8C minus 2C equals it should probably be minus 5. I'm gonna get there. 3 times 12 is 62. Wait, what? It's fine. I had to do long multiplication. Don't tire your brains too much. We've had too much brain rot to do actual. I mean, I know 2 times 12 is 24 at least, but then I was like, do I add another 12? Yes, you do that. Exactly. That's how math is. So you have negative 36 plus 6, which means on this side we have a 30, but it's negative. And then on this side we have a 4C, and it's going to be a fraction again. Because I just have to divide both sides by 4. So when we do that, we get a C equals negative How many? 28. I see problem I do. I don't know. Oh, wait. When I say math problem, I must try to do it mentally. I know, but then your brain gets tired. Just how my brain works. That doesn't look right. What? What do you mean it doesn't? Oh, because it's supposed to be 6 and not 4? Thank you. Darn it. It's supposed to be 6. Because you take 2 out of 8, it's 6. So we divide both sides by 6 and not 4. But at least this side is correct. I'm a software engineer. Yes. Trust me, software engineering doesn't have anything to do with long multiplication. You could just do it. You can write a program to do it. You don't need anything like this. Oh, nice. You're studying computer system information, and I'm leading towards STEM. Yeah, nice. It looks right. Thank you. Yes, but I swear to God, computer science doesn't have as much math. Like, yes, calculus and algebra are definitely, here we go. I'm gonna give it. You're gonna have it. Still, 30. Okay, that's a 5. Nice. The answer is -5. Wait, did you already tell me the answer is -5, -5? You did. You did. Nice. All right, we got there. Did you know I just had to do the 5, 10, 15, 20 with my hands to get to this number? Don't tell anyone. Oh, nice. Show. Yay, we did it. So I'm gonna actually try to respond to the bot now. I don't know if you guys will see it, but I'm gonna do the raid. Darn it! Why did I do that? Sorry. Npin. Thank you. Enable. Oh, I didn't say do that. All right. I'm just gonna try and type it in the chat. Ready. And I truly hope you guys don't need to see it. And you did? Yeah, you did. Okay. In school, I applied to only computer information system, and I'm only paying 60 a month for my SO. Hi. Associate in Science degree.
Anna Shadetich just followed. CL welcomes you.
Thank you. So I figured... Oh, it's fine. Don't know. Well, ReadyBot could not notify. What the hell? Why not? When I finish high school, I want to study civil or electrical engineering. Confession time. I wanted to be a civil engineer as well. I am so glad I didn't. But hey, to each our own. It's not for me. All right. Next is a video that says solve variable both sides. I don't know what that means. I mean, I do know what that means, but I don't know what it will tell us. I hear engineering is a pain. CK? What is CK? Math is cool though. Math is really cool. And I know people who know math who say it's nice. But then I feel like I don't know math sometimes. And then it can look in civil life. What? Okay, that's funny. You mistyped. Okay. I'm like, fine. You made a mistake. I can forgive you this time. But stop mistyping. Says the person who mistypes everything. Yeah. It's interesting where life takes us. And sometimes it's based on decisions, sometimes you just get like steered in directions. Free self-taught path. Oh, right. You want to teach yourself mathematics degree. Okay, nice. Math is easier than biology or yeah, civic, because it has little to no memorization. You just like follow it basically. They just use free resources, but it's all structures basically. And like, this is what Khan Academy is great for, because yes, I'm doing high school math right now, but they have college level math as well. Like, they even have those, I'm guessing, tests, because I know AP, I have no idea. I've heard AP being like test stuff. I'm gonna play the video and see where it takes us. It's a 3-minute video.
So I have the equation.
Okay. Yeah, same. I mean, Khan Academy being one thing and YouTube being the other. Like, how many universities put their lectures there for free? Yeah. Because, like, when you think about it, education was never this easily accessible in the past. So, yeah. How cool is that?
7 minus 10 over x is equal to 2 plus 15 over x.
No.
So this isn't the type of equation that you might think that you're used to solving, but I'll give you a few moments to see if you can solve it on your
Darn
own.
it. Yeah, YouTube is like the best place for learning and procrastinating. And 90% of the time I'm there to watch something in the background. But that 10% of the time when you learn stuff, that's fun.
Well, what we'll see is we can do a quick multiplication of both sides to actually simplify this to a form that we are more used to looking at. So what's probably bothering you, because it's bothering me, is these x's that we have in the denominators right over here. We're like, well, how do we deal with that? Well, whenever we see an x in the denominator...
No, we can't. I was like, can we multiply both sides by x? But then it will go away. And great thing about MOOCs, massive open online courses, is that you can experiment what you enjoy, or maybe even get employed from it. It's you don't. I mean, you could pay for the degree there sometimes, but it's not as necessary. Yeah, or get a degree. Anyway, if it's something you enjoy, as long as you aren't in debt. Not everything is about money. Yeah, I feel like that this not everything about the money is both sides of like spending money to get the degree, or applying to a job to get the money. I mean, the world runs on money, obviously, but also, yeah, like for me, I didn't mind paying for my master's degree. My bachelor's was free, alhamdulillah. But yeah, the whole getting in debt for learning, that part is not good. Yeah, when education is not free, that's very messed up. At least like levels of education, because yeah, math tutors currently studying CS. Oh, nice. That's why you're so smart. I mean, if I had to tutor someone in math, I'd probably need to study first, whatever the material is. Yeah, free degree is always good. Yeah. I am the type of person who enjoys structured education. Not everybody does. Oh, hi. Ooh, we have a
Taffeta_live just traded with 9 viewers.
Hi. Welcome to... I am hiding what I'm doing so that I can scare you with it. Like, reveal it. Or maybe you already know what I'm doing. I have no idea. Hi, Taffeta. I really like your name. I know you were playing something about wait. The gamer in me is like, I don't game. Wait, let me remember the name. Middle Earth, right? That was the name. My brain connected it to Lord of the Rings, so that's why I'm like, was that the name? Oh my god, thank you for the raid, first of all. It's really cool to be a part of this. Yeah. Oh, huh. Wait. Oh no, I'm mixing you with someone else. Oops, you were playing something cool though. I was watching like for 10 minutes before I started my stream. Bendy and the Dark Revival. Cool. Wow. let me show you what I'm playing. Thank you. Oh yeah, so chat is now ReadyBot is saying in chat about this streamathon, which is really cool. A bunch of lovely people from the Twitch Creator Club created this Halloween streamathon, and here is my scary Halloween. I'm doing a let's play of math on Cat Academy, Khan Academy. I'm studying math basically, and what is scarier than that, you know? Yeah. See, thank you. You get it. Yeah, and my cat here is terrified. Very, very scary. Yes. And like, what is more scary is now this is X is a denominator. What? I've never seen that before. What do we do about this? I don't know. I'm gonna learn now in a bit. But thank you so much for the raid. Please feel free to take your time. I think you probably need to rest. I don't know how long was the stream. I didn't check, but it's been at least. Oh, maybe, huh? But yeah, I don't know if it's night or morning, but whatever it is, take your time and rest. I'm not gonna read what is written in chat right now. I'm not gonna read it. I can just say it's very scary. Okay. Yeah. I actually, I'm really, yeah. Thank you. Happy Halloween if you celebrate it. It's fun. I like October. I like the vibes of October. What did I need to do? Uh-oh. Okay. Nice. Making mistakes. There we go. Have a lovely rest. Nice. All right. Okay. So, I actually have no idea what I'm supposed to do with this X. Because if I multiply both sides by X, I feel like it's going to something. Wow. I just checked how many viewers I have and I got really scared. Multiply both sides by X, but X would go away. And no, it wouldn't. Darn it, brain. It would be 2X on this side and 7X on that side, right? I thought X would go away. Okay. Right. Okay, I'm gonna remove the visual where I can see how many viewers I have so that I get less scared. Brain is braining. Brain had some coffee already. Why is brain not braining? So we multiply both sides by X, I suppose. Let's do that.
The temptation is to multiply it by X, but we can't.
Hey, he said it's a temptation, meaning we shouldn't? Let's see.
Can't just multiply one of the terms by X. We have to multiply the entire
Obviously, it's an equation, man. It's an equation.
Side by X. So we could multiply this entire side by X, but we can't just multiply the left-hand side by X. We'd also want to multiply...
Comedic timing. Yeah, that was pretty funny. I was tempted.
The right-hand side by X. And so what will that give us? Well, we distribute the X. We get X times 7 is 7X.
Yeah.
And then X times negative 10 over X, well, that's just going to be negative 10. So you get negative 10 right over there. So the left-hand side simplifies to 7X minus 10. And then your right-hand side, once again, distribute the X. X times 2 is 2X. X times 15 over X. Well, X times something over X is just going to be the something. X times 15 over X is just going to be 15 plus 15. So now we've simplified this to a linear equation. We have the variable on both sides, so we just have to do some of the techniques that we already know.
Yeah, we just continue.
So the first thing that I like to do is maybe...
Should I try mental mathing it? So if we take 10 to that side, it would be just 5 remaining. If we take you on that side, we have 5 remaining. So the answer is just 1, I think.
Get all my x's on the left-hand side. So I want to get rid of this 2x.
Don't distribute, that's illegal. I mean, the teacher said so. What do you expect? Yeah, x is a substance.
right over here, so I subtract 2x from the right-hand side.
Mm-hmm.
Now, and I always remind you, I can't do that just to the left, just to the right-hand.
25, not. Darn it! The answer is 5 because this is a negative. If we take it to that side, it would be a positive, so it would be 25. So we have 5 divided by 25. The answer is 5 itself. Thank you. You're a good kid.
Hand side. If I did just to the right-hand side, it wouldn't be an equality anymore. You have to do that to the left-hand side as well. And so we are left with, let me get that pink color again. The left-hand side, 7x, 7x, 7 of something minus 2 of something, where you're going to have 5 of that something, minus 10. These two x's negate each other, and you're left with equals 15. Now we can get rid of this negative 10 by adding. So I can 5x
there we
and
go.
5. Verify that this actually worked. So let's go back to the original equation. We have 7 minus 10 over 5. This needs to be equal to, I'm just taking our 5 and substituting it back here. This needs to be equal to 2 plus.
Hey, adds time. Hello. Add time. Add time means rest time. We chill when there are ads. Anyone not in ad hell? Let me know. How's your day going? Do I have a thing coming up? Oh, lesson 2 already. So no tests. We start with a new video. Lesson. Where am I? Okay. Community is back. Welcome back, community. Honestly, if I am like conscious, I can't snooze ads, but welcome back. I only have math, physics, chemistry, and biology in my curriculum aside from language. Isn't that like everything? If you're on the scientific path, then you won't have history or geography or other stuff. That is, yeah, languages, math, biology, physics, chemistry. That's a normal high school curriculum. Maybe sometimes you have other stuff. I don't have those subjects. Yeah. I also did science in high school, so you just get separated from. But like in middle school, you do have to take history, biology. Geology. What else is there? Economics. That's also one that I didn't have to take. I was looking at, when you have to study, how many times do you count how many pages you have left? Geography. Yes. Geography. What is geology? I don't know. It also has to have to do with Earth because it's geo. I think that's a department. Yeah, no, that's definitely a department at universities, because they study the layers of Earth, I think. I actually really like everything. Studying rocks and landmass, exactly. I like I learned that I like all the sciences because obviously geography and geology are both. I guess geography just has to do with countries, but yeah, geology is a science. Okay, still, I feel like I would be content whatever path I would have taken. I'm really happy where I am, obviously, and also very frustrated most of the time. Yeah, so we are almost finished with this video. We're going to do this one and then get to the quiz. And is that it? 2 quizzes, 3 quizzes, and a unit test. My plan is to stream for how many more hours? It's been 1 hour and 10 minutes. I got, what's the word? Overconfident, and plan to stream for 2 more hours. But maybe an hour and a half, depending on when the other person starts streaming. I'm gonna check up on them. But yeah, that's the plan. Let's see how I'm guessing I'm gonna get to quiz 1, but let's see how far we can go from there. And 15 over 5.
Plus 15 over 5. So this is 7 minus 10 over 5. This is just 2.
Yeah, let's see how much we can endure. I know I can talk for that long. We'll see. Sometimes I get like called and say, "Oh, you're not done yet." So let's see if I get that notification from my family. Yeah, I am very sure I can posted a cool ML video on Discord. If you run out of steam on maths, that's a good idea. Thank you. I did get a Discord not notification, but like I saw it on the notification of my phone. I obviously can't click it there, but yes, thank you. I may do that. Let's get to quiz 1 and see where we go from there.
Needs to be equal to 2 plus 15 over 5, which is just 3. So 2 plus 3.
I like this arrow. Look at that.
7 minus 2 is 5. 2 plus 3 is 5. 5
Yay.
is indeed equal to 5. And we are done.
5 is indeed equal to 5. I like the way he said it. And we are in lesson 2. That has to do with parentheses and then 2 practice sessions, another video, a practice session, and a review, which I doubt I will do, but let's see. All right. I can't read this. Where am I supposed to see this? Well, we'll see. Ready, bot? You're doing too much. I may take away your privileges. Okay, let's play the video.
We have the equation -9 minus this whole expression, 9x minus 6. This whole thing is being subtracted from -9 is equal to 3 times this whole expression, 4x plus 6. Now, a good place to start is to just get rid
The voice is lower, right?
of these parentheses. And the best way to get rid of these parentheses is to kind of multiply them out. This has a -1. You just see a minus here, but it's really the same thing as having a -1 times this quantity. And here you have a 3 times this quantity. So let's multiply it out using the distributive property. So the left-hand side of our equation, we have our -9. And then we want to multiply the -1 times each of these terms. So -1 times 9x is -9x. And then -1 times -6 is plus 6, or positive 6. And then that is going to be equal to, let's distribute the 3. 3 times 4x is 12x. And then
If we take a common 3, wouldn't we overcomplicate it, maybe? It's just thinner. Oh, tiny. What? Huh? Less deep due to different mic. Probably. Yeah, it looks like an older equipment. If we take a common 3, we'd still need to do the distributing. Like, multiply it again. But like a Nokia phone. You know what? I can actually check how old the video is. Wasn't the last one 13 years old? CL has learned not to show too much. Okay, I'm getting my own video. 15 years. I'm getting my own video recommended to me. It is from 2010, June 11th, 2010. And it's been viewed 1 million times. How lovely is that? That's very lovely. Oh, right. I was supposed to be here. Yeah. Here we are continuing. Honestly, I am very happy how good my stream is. Knock on wood. Is there any wood here?
3 times 6 is 18. 3 times 6 is 18. Now what we want to do, let's combine our constant terms if we can. We have a -9 and a 6 here. On this side, we've combined all of our like terms. We can't combine a 12x and an 18. So let's combine this. So let's combine the -9 and the 6 are two constant terms on the left-hand side of the equation. So we're going to have this -9x. So we're going to have -9x let's see, we have a -9 and then plus 6. So -9 plus 6 is -3. So we're going to have a -9x, and then we have a -3. So -3 right here. That's the -9 plus the 6. And that is equal to 12x plus 18. Now we want to group all of the x terms on one side of the equation and all of the constant terms, the -3 and the positive 18 on the other side. I like to always have my x terms on the left-hand side if I can. You don't have to have them on the left, so let's do that. So if I want all my x terms on the left, I have to get rid of this 12x from the right. And the best way to do that is to subtract 12x from both sides of the equation. So let me subtract 12x from the right and subtract 12x from the left. Now, on the left-hand side, I have -9x minus 12x. So -9 minus 12, that's -21, -21x minus 3 is equal to 12x minus 12x. Well, that's just nothing. That's 0. So I could write a 0 here, but I don't have to write anything. That was the whole point of subtracting the 12x from the left-hand side. And that
Okay, I'm looking at the chat. You took out a common 3. Would you take it to the other? Would you then? Oh, now I get your point. Then you would divide both sides by a -3. So then that would go. Nope. No. Can you take a? Yeah, you could. Okay. Wait. What? But you cannot take a common 3 from this. Yes, you. We already have a common 3. Ah. Okay. Your brain works great, Abbott. Good job.
is going to be equal to, so on the right-hand side, we just are left with an 18. We are just left with that 18 here. These guys canceled out. Now,
Let me share my evil plan. Oops. I checked, and Restream is saying congratulations on 100 messages today. My evil plan is to frustrate you guys so that you guys message in the chat. It's working. That's me apologizing for being frustrating.
let's get rid of this -3 from the left-hand side. So on the left-hand side, we only have x terms. And on the right-hand side, we only have constant terms. So the best way to cancel out a -3 is to add 3. So it cancels out to 0. So we're going to add 3 to the left. Let's add 3 to the right. And we get the left-hand side of the equation. We have the -21x, no other x term to add or subtract here. So we have -21x. The -3 and the +3, or the +3, cancel out. That was the whole point. Equals, what's 18 plus 3? 18 plus 3 is 21. It's 21. So now we have -21x is equal to 21. And we want to solve for x.
Why does my brain think, what's 9 plus 10? I heard the 21 and I'm like, yeah, that's what's 9 plus 10.
X. So if you have something times x and you just want it to be an x, let's divide by that something. And in this case, that something is -21. So let's divide both sides of this equation by -21. Divide both sides by -21. The left-hand side, -21 divided by -21, you're just left with an x. That was the whole point behind dividing by -21. And we get x is equal to, what's 21 divided by -21?
Negative
Well, that's
1.
just -1.
Yay.
Right? You have the positive version divided by the negative version of itself, so it's just -1. So that is our answer.
See, each time it's like, and we did it. I see the video left. That's because he's going to try and put it back inside. Fine, do that.
That is our answer.
Let's do some
-1 into
skips.
that a different color. That's there. 9 times, I'll put -1 in parentheses, left-hand side. So when I minus, -9, 9 minus, which is 6.
Okay.
So that's what we get on the left-hand side of the equation when we substitute x is equal to -1. We get it equals 6. So let's see what
On the
happens when
other
we substitute
side?
-1 times 4 times, that is 3 times -4 plus 6. -4 plus 6 is 2. So it's 3 times 2,
but
which
it's
is
negative.
also 6.
Oh, it's
So
not
when
negative.
x is equal to -1, you substitute here.
Hold up. Right, because we take 4 out of 6.
The left-hand side becomes 6, and the right-hand side becomes 6. So this definitely works out.
Good job. And now we have to do that. Parentheses. I like these faces. They don't. They look like they're like, can you do it? That's what it looks like. Here we go. We just start off, hit the ground running. We have the 2. Yes, not gonna lie, faces look creepy. No, they look curious. Like, can you do it? The eyes are cute, creepy, which is fine. 4 equals a 5 minus 4 minus 2 and an S. Why does my S look like a Z? Did I write it correctly? I hope so. So we're just gonna start distribution. We have a minus 10 over here. We have a minus 20 over here. Parentheses with... Oh, that's smart. Working with parentheses. That was smart. Very Yoda. But in parentheses. And we have the 2s plus 4. We just start moving around. I'm just going to do it in one step. You go here, and you become a minus. Don't forget that, okay? And then you go here. You know what? Okay, it's fine. I'm going to get over my fear of the negative numbers. So here we have the negative 20. We have the negative 20 with a negative 4. And we have a positive 2s with a positive, because you were already negative on that side, 10s. Why are we adding to it? Here we have a 12s, and on this side we have a negative 24. Yay! We got there. Yes, Abbott and I got there at the same time. There's just a lag, you know. We divide both sides by 12. And we have a minus 2. Oh, minus 2. I think. S is minus 2. Because we still have this negative here. Right? Oh, thank you. Thank you for the confirmation. And here we go. Next. There are 4, right? Yeah, there are 4. It's fine. We can do it. Yeah. Why? Oh, right, I was clicking the wrong button to get the pencil. Let's see if we can just like hit the ground running with this. We can say negative 12g minus 6 equals, I guess we have to do the same for this negative one. Negative 13g minus 2. Nice. Oh yeah, you mistyped the equal sign in the negative sign. So we start moving things around, reorganize this lovely home. You go to this side, and you go to that side. And I see a negative 12g with a positive 13g, a negative 2 with a positive 6. Here we have 1g. I don't have to write that one. And we have a 4. And g is 4. Yay. Better be right. Woohoo. Nice. Thank you. All right. That one looks simple. 90 minus 90. That's funny. Is that supposed to be a joke? Because it's 90 and a 90. Negative t equals 9t minus 90. And then we can just let's just go do that. Take 90 out of both sides. We have a negative t minus 9t. and negative 9t on this side. Here we have a negative 10t with a negative 9t. And if we divide both sides by a negative 10, we get t equals 9. Yes. Oh, 90. A lot of t's, not p's. Was that a mistype? I mean, I don't have 9 t's a day, but I do have a lot of t's. The answer is 9. Right? Because it was 90 over 10. Ah, yeah. Okay. Because I thought I forgot. And then let's do this as well. U here, and then again U here. We have the 3 minus 2b, but plus 2. No, 4. That's a 4. Because both are negative. And then on this side, we have the 2 minus 7b. So, we have two things. One of them is we have a positive 4 and a positive 3. So we have then minus 2. Is that a b? Dear God, why does it look like a 26? We have a positive 7. Is that correct? Yes. And then on that side, we just have the 2, 7b. And then if we move u here, and then we move u here, we get a... I am addicted to tea. I like tea. I like the vibe around tea. Like I have tea at work as well, and that vibe is me with on my laptop or my computer. Wait, don't tell me the answer yet. I'm gonna get there anyways. It's fine. If you tell me the final answer, it's fine because I won't know how you got there. Negative 2b. I like the vibe of like drinking tea with people. That's what tea means to me. We have a positive 7b. I feel like I associate coffee with like sitting down and like doing something, whether I'm like working, studying, editing something, all of that. Like coffee is feels more solitary to me. Could be wrong. Other people might have different experiences. 2 minus 7. And then I'm so sad, but the word 7 has been like like everybody likes the number 7 because it's a fancy number, but like over the past few weeks it's lost its meaning for me. 7, that's a 5, not a 2. We have a 5b and a negative 5. Oh right, it is -1. Yay! Exactly. The thing you just typed in the chat. Did you know it's dictionary.com's word of the year? I read it on Reddit. And the answer is -1. And I started learning to say negative instead of minus. Woohoo! I am progressing forwards. Hey! Nice. We did it. 5% on unit 2, I suppose. Oh, that's really slow. Let me refresh this part. We have 2 more. We have more? Okay. We have 1 more and 2 more. Yeah, okay, that makes sense. We have 2 more practices and then a quiz. Cool. But like after this we have a quiz, so that's a good thing. I finished this video. Don't make it look like I have finished it. Another exercise coming up. Let it be known that when I posted this devil emoji in the chat, I had to Google it. Because I don't know why Twitch didn't give me the emoji on computers. Yeah, okay. Ready to practice. I feel like I like the blue one the most because it reminds me of the universe. or something. I think they're supposed to be gems, but it reminds me of like pictures of the universe or like Jupiter. Oh no, this doesn't look nice. There we go. Okay, I was not distracted and I was not doing something on the other screen. 9f equals a half of oh, that's not difficult. It's just a half of 12 and a minus 2. So a half of u is a 6f, and a half of u should be just a minus 1. And then we have the 9f here. And if we take 6f away from both sides, we have a 3f here and a negative 1. So the answer is negative 1/3. Hopefully. Oh, you're already there. When I'm looking at chat and I see your answer, huh? Okay, yeah, thank you. Yep, improper, because it's not simpler, but it needs to. Anyway, yeah, it makes me feel nice that we got to the same answer. Next question. If we, you know what? I appreciate whoever wrote these questions because they're not that difficult, even though they look fancy. This just becomes a 4, and this becomes a 5. I hope. That better be the case, because the 0 goes away. So we have a 4 plus 5g equals 4g. Yay, thank you. You go there, and if you go there, I don't have to move it, but I will move it because that's how it should work. We get a 5g minus a 4g and a negative 4. And then we have a 1g equals negative 4. And that should be the answer, hopefully. Woo! I said I like equations, and I like equations. But when the numbers get too big, I just get scared. 3t minus 18. And here, if we do this, we get a negative 12. And this dies, so we get a negative 3t. Uh-oh. Oh. No, uh-oh. Because if this t goes that way, it becomes a positive. And this 18 goes this way, it also becomes a positive. So we have the 3t plus 3t equals well, why write the negative first? Let's write the positive first. 18 minus 12. And that is a 6 on this side and a 6t on this side. The answer is yes. You can take a common 3 on second line. That is definitely true. We can have it be a 3t. Is that how it worked? And then on this side we would have a 3, 6, and a 3. Wait, no, 4. And then we would have a 2. Uh-oh. Okay, now I can snooze and add. Woohoo. Minus 6. Oh, first line. That, I guess that would be the first line for me. Second line after doing this part. Good point. Anyway, right now the answer is a 2 because we get a divided by 3 and a divided by 3. I like your thinking, because if we take 3's from both sides, the t would be free. The answer was a 2 and not negative. It was positive. Oops, I messed up. Was it negative? Darn it. Can't even go back. It was 6 divided by 3, wasn't it? Well, here we go again. we do this, which is negative 12 and a negative 3t. And if we take the 3 out from here, to listen to your advice, we would get the 3t, oh, nope, 3t minus 6 and a 3, I mean it was, yeah, no, okay, negative 4 and a negative t. And we can just kill the 3's on both sides. Then we would get a t minus 6 equals negative 4 and a negative t. Here we get 2 t's and then a 6 minus 4. Why was my number different? The answer is 1. Why? Well, I was wrong first time. For sure. Confused. How did I get to a 2 when it was a 1? Anyway, thanks for your method. It's actually pretty... I don't think I'm used to it. Here we go. Now this one is not my style, but we can do it. We get a half of a 7 and a half of a 4. The half of a 7 is 3.5, which is how I'm going to write it. And a 2. And on that side, we have a 7 and a negative 1.5 d. And a d is supposed to be here. You want to avoid big numbers, and simplifying helps. For sure. Okay. What we do is, this is a 1.5, not 15. I wrote it as 15. I'm going to take you all the way there and take you all the way there. Like sometimes you can tell how the person was taught first time. Me moving the numbers around instead of dividing and multiplying is like, I feel like that's how I was taught. Which again, I like because that's how I understand it. We have a plus 1.5d and 7 minus 2. That's a 4 and a 5. So we have a 5 here. And a take 2. That's a 5. Hey, answer is 1. I hope. Let's see. Wait, if every answer is 1, but no. That's question number... we get a bonus question because I made a mistake. Cool. Our bonus question. We get a... Okay, that's 1.5. Which is like half it and then give it back. So this should be a 3. I'm just gonna do it like this. We have a 10, 0, 1. We have a 2 plus 1, 30. And then we get the 0 back. Yeah, okay. 1.5 of a 2 is 3. So you are a 3 minus 1.5 of 4 should be 6. Let's do it here as well. And we have a 4. That's a 0, 2, and that's a 6. Yay! So that's a 6h equals 6h. You are a negative, so we have like a 12h equals 3. Ah, yeah, okay, 1.5 means a 3 twos. True. Yeah, 1.5. Yeah, that works. I remember the coffee comment on that. And here, h would be 3 divided by 12, which this is a 4 and this is a 1. So it's a 1/4. Answer is h is 1/4. Hopefully. We have an ad incoming in 10 seconds. I'm gonna pause. Yay! I'm gonna pause after that. Okie dokie. Probably ad time for the next 2 minutes. I don't know who's in ads and who's not. If you're not, let me know. And if you are, cool. I can probably message. Ads question mark. Honestly, I'm really happy with the status of my stream. I shall continue as is. Not for you, not for me this time, or yet. I mean, it did say ad incoming, and now I don't see a message that says ad ongoing. Ongoing, and now it is. There we go. Okay, what about now? Ad break after 1.5 minutes. I'm gonna go ahead and check on the raid thingy. Raid thingy. Now ads. Okay, I knew it. Thanks for letting me know. Wow. Okay. So I need to have this opened on a tab so that when it happens, wait, no. Yes. Ah, see, I know I made a mistake. Okay. Ads. Oh, hi, you're back. What's up? The ad thingy says it will be finished in 10 seconds, maybe? 3 seconds. 5, 4, 3, 2, 1. Cool. And we're back. Nice. Alright, I'm gonna close this and refresh this and share the screen again. Ta-da! So, we have one more practice session. Yes. And then we get to the quiz. And I'm hoping it's going to be nice. Oh wait, a video and then a practice session. When I click this and I see a percentage here, I'm like, good job me. I'm progressing. What did I do? If you click on here, it goes back? Cool. No, I'm ready to watch a video. Reasoning with linear equations. Okay, I'm reasonable.
In many other videos, we've taken equations like this and tried to, quote, solve for x. What we're going to do in this video
So instead of trying to solve for it, we're going to try and reason with it?
is deepen our understanding a little bit about what's going on and really think about the notion of equivalence or equivalent statements. So let me write that down. Equivalence. Now, what do I mean by equivalence? Well,
That is some beautiful handwriting.
I'll use this equation here to essentially keep rewriting it in equivalent ways. And I'll talk a little bit more about what that means. So one thing that I could do to essentially write the same equivalent statement is I could distribute this 3 onto the x or onto the x plus 1. And then this part of it could be rewritten as 3x plus 3. And then we have minus x is equal to 9. Now, what I will say, or what it might be obvious to you on some level, is this top equation and this second equation are equivalent. What does that mean? It means if one of them is true for a given x, the other one will be true for that same x as well, and vice versa. And we can write other equivalent statements. For example, if we were to combine x terms here, if we were to take 3x and then minus x right over there, I could rewrite that as 2x, and then I have plus 3 is equal to 9. Now, all three of these statements are equivalent. If there's an x, where 2 times that x plus 3 is equal to 9, then it is also the case that 3 times that x plus 1 minus x is equal to 9, and vice versa. If there's some x that would make this top equation true, then it's going to make this last equation true. And we can do other equivalence preserving operations, and you've seen them before. You could subtract 3 from both sides. In general, if you are adding or subtracting the same value from both sides, it is equivalence preserving. If you're distributing a value like we did in that first step, that is equivalence preserving. If you combine like terms, so to speak, that is equivalence preserving. And so here we'll do an equivalence preserving operation. We'll subtract 3 from both sides, and you would get 2.
Equivalence preserving operation. That's a new thing to me.
X is equal to 6. And once again, any x that satisfies this last equation will satisfy any of the other equations, and vice versa. Any x that satisfies any of these other equations will satisfy this last one. And so they are all equivalent to each other. And then another equivalence preserving operation is to multiply or divide both sides by a non-zero constant. And so here we could divide both sides by 2. 2 is not 0, and it's constant. And if we did that, we will get another equivalent statement, that x is equal to 3. So any x that satisfies this, and there's one, x equals 3, would satisfy the other ones, and any x that satisfies any of the other ones would satisfy this last one. So these are all equivalent. So one way to think about it, adding the same number to both sides of an equation, that is equivalence preserving. Multiply or dividing both sides by a non-zero constant value is equivalence preserving. Distributing, like we did in this first step, equivalence preserving. Combining like terms, equivalence preserving. Now you're probably saying, well, what are some non-equivalence preserving operations? Well, imagine something like this. Let me just start with something.
Okay. So, yeah, ReadyBot is telling me to rate myself. So, hi, I'm rating myself because I have the other slot. Equivalence preserving. Something that would not be equivalence preserving is just doing an operation on one side and not the other, right?
Very obvious. If I said that x is equal to 2, a non-equivalence preserving operation is if I were to add or subtract or multiply or divide only one side of this equation by a value. Let's say I only added 1 to the left side. Then I would have x plus 1 is equal to 2. And it is not the case that anything that satisfies this second equation satisfies the top equation, or vice versa. X equals 2 clearly satisfies the top equation, but it doesn't satisfy the second one. That's because we did a non-equivalence preserving operation. Likewise, if I only multiplied the right-hand side by 3, I would get x is equal to 6. Well, by only multiplying the right-hand side by a value, it's not the case that anything that satisfies x equals 6 will satisfy x equals 2. That is somewhat obvious here. Now there's a little bit trickier scenarios. Let's say we have the equation 5x is equal to 6x. Now one temptation is...
I mean, the answer is a fraction, but it's still an answer.
Well, I want to do the same thing to both sides.
Yes.
I could just divide both sides by x. What'll happen in that scenario?
I would actually take this x away to here, keep a 1 on this side, and say 6x minus 5x, which is x, and the answer is 1.
Well, if you divide...
Wait, it can't be. Anyway, let's see.
Both sides by x, you could think that an equivalent statement is that 5 is equal to 6.
No.
And you know that there's no x for which 5 is equal to 6. You can't make 5 equal 6 or 6 equal 5. And so this would somehow make you imply that, okay, there's no x that can satisfy. If you assume that these were equivalent statements, you'd say there's nothing that could satisfy 5 equals 6, so maybe there's nothing that satisfies this top equation. But this actually isn't an equivalence preserving operation, because you're actually dealing with a scenario where x is equal to 0, and you're dividing...
It's 0? Oh, if I move this away, we don't have a 1 left, we have a 0 left? Of course, because 5 cannot be equal to 6, but if we multiply both, like if this is 0, then yeah, it would be equivalent. I guess dividing by x should not work because no, does it? I don't know. I mean, yes, we know it's 0 here, but even if it's not, you never know. I didn't realize I leveled up to level 5. I'm level 5.
Dividing by 0. And so you have to be very careful when you're dividing by a variable, especially if the variable that makes that equation true happens to be 0. And so in order to be clear that you're preserving equivalence here, the way that I would tackle it is I would subtract.
Often a mistake beginners do when solving quadratic equations. I'm gonna nod and assume quadratic equations. Do I know what's a quadratic equation? I know I've heard it a bajillion times. Quad means 4. What else? Attic? Well, that means the top part of a house. No, it has to be radic. Anyway.
5x from both sides. And if you do that, and that is an equivalence preserve.
Oh, okay. Any equation that has squared or like variations of squared. Max term is... Oh, max is squared? Okay. So, yeah. I don't know what I call these equations, but I guess now I know how to talk about them.
Preserving operation. You could subtract that expression from both sides, or that term from both sides. And then you would be left with 0 is equal to x.
If I do... yeah. Okay. 0. If I do... adding and subtracting, 0. But if I do multiplying and dividing, 1. Example, yeah. Oh, polynomial, yeah, I said it correctly, is the one where it has like multiple, I can't say squared, I have to say something else. Raised to other numbers. Is that correct? Okay, that is really helpful because I have a polynomial. Oh, what was that? Oops, sorry. I have a polynomial. Isn't there another n somewhere? I don't know. Homework, and I really need to get to it. Okay.
X. And now 0 equals x, and 5x equals 6x. These are equivalent statements. They are equivalent equations. Anything that makes this one true is going to make that one true, and anyone that makes that one true is going to make this one true. Now, one last thing, you might have heard me say you can multiply or divide by a non-zero value, and that's going to be equivalence preserving. And hopefully you just got a sense of why dividing by 0 is not a good idea. In fact, dividing by 0 is always going to be a strange thing, and it's undefined. But also multiplying by 0. For example,
why would I do that?
If I had, let's say, actually, let me start over here. If I had 2x is equal to 6, and if I were to multiply both sides by 0, I would get 0 is equal to 0. And 0 equals to 0 is true for...
It's true, but it's not giving you the answer to your equation of the variable in your equation. It's like saying, just throw everything away.
Any x. 0 is always going to be equal to 0. But the problem is that first statement isn't true for all x. It's only true for x equals 3. So these two are not equivalent statements. They have a different set of x's that will satisfy them. And so you have to be very careful when you're dealing with things that are either are 0. You can add or subtract zeros. Obviously, that's not going to change things much. But when you multiply both sides by 0, you can start getting things that are not equivalent statements. And when you multiply or divide by things that could be 0, like variables, that also is a dangerous game to play.
And wait, we live with danger. We are danger. All right. creepy faces that are cute. Here we go. Oh, I love a multi-select because I get lazy and just choose something. Wait a second. Oh, the answer is, are these equivalent? So, yes, obviously. No. Yes, 100%. Yes, they are equivalent. What I would do is just give the 3 to both. 3 and a 6. The end. It's equivalent. So what's happening? How can we get equation B from A? We take 3 out. The common value. Whoa. Multiply/divide both sides? I don't think so. Rewrite one side by combining like terms by using distributed property. Yes, we did the this one. We didn't do both sides for sure. Multiply, divide one side by a non. We didn't do that. We did this. I suppose combining like terms. No, I don't think so. Okay. Based on previous answer, are the equations equivalent? Yes, they are, in my opinion. Check. Good. Nice. Math. 4 questions as per usual. Answer 2 questions about equations A and B. How can we get B from A? So we have A, how can we do B? This side has not been changed. This side is... Wow. What is this? The 2 is just taken away. And they're not equivalent. So definitely no. But, so one side has been subtracted from, well, added to. The 2 has been taken away. But it's a negative, so it means it's been added to. And that is my final answer. Nice. My math is mathing. Do I need to check something? Yes. Nice. No need to. Same with here. Oh, x is... Okay, now this is equivalent. The answer is yes. Because we have subtracted 2x from both sides. So the answer is both sides. Where's the both sides? Add, subtract, quantity, both sides. Subtract same quantity from both sides. And I will say quantity because I suppose x could be a quantity, but let's see if that's wrong. It's not wrong. Nice. Final question is... Oh, now it's a both sides situation. We took 3 away. We did... Well, I don't think it's add or subtract. There we go. Multiply, divide both sides by the same constant. And yes, they are equivalent. Final question. Nice. That cling is really loud. I've actually tried to limit the voice, but it's still surpassing it. Nice. I think we get to the actual quiz now. I'm not gonna review. There's a practice. Okay, I'm gonna do the practice, but I'm not gonna review. Solve for B. Is this optional? I don't know. Anyway, looks like it. Can I skip this? I'm sorry. I apologize. I really want to skip this and go to the quiz. Well, nobody stopped me. You're already proficient or master of these skills. There's no more levels to reach. What do you mean? I still have to do the quiz though. I'm gonna do the quiz anyways. Alright, we have 5 problems. And here we go. Let's start writing. I guess I'm gonna have to do the distributing for now and see where we get from there. We have a fourth of a k equals minus 3/4k plus 9. Then, I'd rather take this 3 away, but if I did that, then this would change, and it's not really possible. Anyway, I'm gonna move you to that side, and that's it. That's all I'm gonna do. So we have the 1/4k plus 3/4k, and since this is equals 9, since this is addition, this plus this happens, but this remains, right? That's how I remember anyway. So we get a 1 basically. We get a 4/k. Oh yeah, see, that makes sense. We have a 3/4, and we have 1/4. We mix them together, we get a 1 full thing equals 9, which means k is 9. Ta-da. That was nice. Yay. Next question. We get A. I think that solving math problems from a book with a pen and paper is far better than online. I'm technically solving it with a pen, not paper, but I still have a pen. Yeah, I get your point. And I am a pen and paper person, but also I'm not gonna put these in a notebook and save them. I don't see the reason for it. I'm not gonna do exam about it later. But I get your point as a student, you know? We have 4a plus 5 equals 2. Screen is black. Okay. Plus 3.25. That's just mean. A. So I'm gonna do some moving arounds. You go here, and you come here. And when we do that, we get a 4a minus 3.25a. Oops. Okay. Equals 2 minus 5. So we have a negative 3 on this side, and on that side, we have a 0.75. Correct? A. Because we're taking 3 1/4 from a 4, so we get a that. And if I were to write this, it would be 3/4. Correct? A. And this. If we divide both sides by 4, I wouldn't do that. I shouldn't do that. So, why do I remember something about a this and a that? So you're 1. Why do I remember something like this? Well, I guess I'm gonna have to multiply both sides by 4, which is literally what this means, doesn't it? Control Z, Control Z. Let's write it with a different pen. We have a 4. That's not a 4, that's a 3. You are a 4, and you are a 4. That's correct. Yay! I'm like vaguely remembering stuff from high school. I really loved my high school teacher. She was a lovely person. So we have a 3 on this side, and 12, and then an A, and I guess if we divide u by 3, we get a negative 4. Huh? Uh-oh. Wait. Did I mess up? Okay, the error things that I did was because I vaguely remember from high school. The answer is negative 4, right? I'm right? Can you double check before I send it, because this is a quiz? Oh, 1/4 would also, okay. Oh, here, like it would be 3 and a 1/4. Okay. So I'm gonna go ahead and, ooh, did not see that one. I'm gonna go ahead and do my -4 and hope for the best. I suppose I could add it back and solve for it. Yay, thank God. Oh, I like these types of questions. And it is, so we just put these two together. We just did some add, subtract one side, but it was not a quantity. It was a like term. Yay. And yes, they are equivalent because, yeah. Answer is a yes. Check. Nice. 2 more questions left. Okay, can we brain math this? I feel like I saw this question just a minute ago. We have a 4 and a 5. 5g and a 4 here. Well, 4 plus 5 equals 4g. And this here, if you go there, you become a 5g minus 4g. That's not a 4. And then you get a -4 on that side. So we get a g equals -4. And that's 2 -4s consecutively. And I'm like scared. The answer should not all be too similar. There we go. I feel like they're doing this to mess with you. They're like, wait, I just had the same answer. This cannot be correct. We have let's just take you there and take you here and just start writing it. We have a 4. That's not a 4. It's been a while since I've written x. 4x. My teacher was like, you need to write x like this, because if you write it like this, you're just gonna mess up. So I know we have a -5x. We have a 7.2 minus 8. For this side, we have a -1x, so a negative x. And on that side, we have a 0.8. And the answer is negative 0.8. I'm going to write it as negative 0.8. And not have it be, I guess, hold up. So 8/10 would be, if you divide both by 2, would be a 4/5. So both answers should be correct. Either a 4/5 or 0.8. I'm going to write 0.8 and hope for the best. Yay! I'm guessing both answers should be correct. Did I just finish the quiz? We're going to get a celebration. Let me just volume down. Ta-da! Good. Nice. Do we continue? Question mark. What is the lesson 3? We finished this quiz, so you need to refresh yourself. Nice! Would you look at that? I'm gonna snooze this ad for a second. So it has a block at the top, and when you finish it, it attaches the block to itself, which is really cute. We have analyze the number of solutions to linear equations, like having multiple solutions, or creating an equation with no solution. Nice. Kiowa. I am reviewing my life choices. ICT in my curriculum is too easy. ICT is information communication technology. So like computer. It's called an ICT. But like more than computers, I suppose. Nice. Well, that's great. I'm glad that you are enjoying that. I am eyeing the video that I got on Discord. What is it? Pre-training under... Ooh, can we watch it? Hold up, let me change the screen. Mute the screen and click the link. Bring it to this screen. Oh, it's already muted. That's a good thing. And it's a seminar from 2 weeks ago with a pre-training under infinite compute. Is it the same? Oh God. Yay. Yes. Hold up. Let me get back to my brain. Small question. Very small question. Oh God. There we go. Now I'm ready. Okay, so that's the video, and that is screen sharing. Here we go. So it's from ASAP seminar series. You said this is they'll explain about 6 minutes in why we should care. Okay. All right. I'm actually reading what you wrote. Maybe worth a watch. From Stanford. Okay, got it. I thought it's Anthropic. I don't know why I thought it's Anthropic. Because I still have not read this blog. Cool. Really? It's about alignment. Cool. All right. From Stanford. Here's the paper and the speakers. Pre-training under infinite compute, meaning infinite. So I'm gonna play it for a second, and you guys will tell me if the audio is reasonable. I mean, I will see it, but still, you guys, I would like a confirmation. And then I'm gonna put on CC. So, yeah. Of course, it's muted. It's muted. Hold up, it's muted on my side. Here we go.
Hello everyone, welcome to today's CSF seminar. I'm Sonia. I'm really excited to host today's talk. Today we are very fortunate to have two speakers from Stanford University.
Wow.
Konwoo Kim and Suhas Kotha, both PhD students working on large-scale language model pre-training. Today they will be presenting their recent work titled "Pre-training on the Infinite Compute," which explores how we might rethink pre-training when compute is abundant and data is limited, including new insights on regular.
Well, I guess it would have been nice if we had the rest of the thing, like infinite compute and limited resources. Like, I feel like this could be, there's place for it in the title. The title is very small. Paper is same thing, right? Yep. Okay.
Regularization, scanning laws, and examinings. Really glad to have you two both here, and please take it over.
Oh, thank you. You want to introduce yourself? Yeah, so hey guys, I'm Suhas. Hi.
Okay, audio is not perfect, but it's okay. What is infinite compute? To my understanding, and we can actually read this abstract. Why did I think subtract? Like, as many servers as you need. Like, oh God, voice is going away. I thought I could yap forever. I'm gonna drink something for a second. Okay, voice sort of back. Okay. I'm guessing it means you don't have any problem with how many like GPUs you have, something like that.
Oh, go get a glass of water.
I don't have water with me, actually.
Akibule bid just redeemed Monty Python hydrate water.
I sipped coffee, which works, sort of. And then I cleared my throat, which is the thing that works more, because I needed to mute the mic. Anyway, TMI. Since compute grows much faster than web text available for C, yeah, well, I mean, is that the case though? We ask how one should approach pre-training under fixed data and no computer restraints, like as many GPUs as you want, as much storage as you want, RAM and all of that. We first, I guess GPU would help with RAM. Anyway, we first show that existing data constraints approaches of, data constraint approaches of increasing epoch count and parameter count eventually overfit. Obviously, if you have limited data and you just train on it forever, it's just going to be the data. And we significantly improve upon such recipes. I like the word recipe in computer science because it means something like a method, right? I guess it means the same thing in kitchen cooking. There we go. By properly tuning regularization, finding that the optimal weight decay is 13x larger than standard practices. My brain needs to think about what weight decay mean. I know my brain is thinking residuals, but that's different. I know what weights are. I forgot what weight decay is supposed to be. Since our regularized recipe you know what? I can watch the video. I should probably watch the video. Even hey, just so you want to know, has started their stream. Nice. They're probably getting ready. When you're ready to rate, just type right now, and they will explain all of this. I know, right? Except what decay is. Okay, it's fine. I should probably let them talk because I technically have 40 more minutes of the stream. This video is an hour and 17 minutes. I'm just gonna play and let them talk, even though I'm guessing their audio is not optimal. It's from a room instead of a microphone. I don't know why I'm so picky about audio. My audio is not the best, but anyway.
Hi everyone, I'm Konwoo. Yeah, so today we're going to be talking about pre-training under infinite compute. There's a lot of slides. Feel free to ask a lot of questions and please interrupt us in the middle. And please, nice. I guess we'll get started then. Cool.
Okay, let's see.
So I guess the motivation for this work is that language modeling is working really well these days. And a large part of the success that's driving a lot of language model working is because of pre-training. So training these models that generate that match the distribution of internet web text. And these pre-trained models are really good.
I actually have a question about the text being limited but not compute. I won't say this is a correct statement. Depends. Maybe like a few companies have unlimited compute. But wait, text is now getting replaced with generated text, which I wouldn't say text is limited, but I can say maybe internet is becoming too much AI text. So that could be like one thing. And like saying trusted resources for text are limited. Let's see if that's what they're saying. No, we have an ad that I can't skip in a minute. Whoops.
Especially because they provide wonderful initializations for intelligence and all sorts of downstream tasks. So for example, in 2020, when GPT-3 was pre-trained for a large enough model for long enough, people found that these models were capable of in-context learning. So these pre-trained models provided these really good initializations for intelligence just at the prompt layer. Closer to around 2022, people have really went seriously into instruction tuning and RLHF and alignment and fine tuning, and found that only sufficiently strong pre-trained models really maximally benefited from RLHF, and these smaller models weren't really benefiting from all these sorts of things. And once the pre-trained model was good enough, instruction following came as a result.
Instruction following.
Most recently, perhaps around last year, DeepSeek found that when they RL these models, these really strong pre-trained models, they're able to unlock these reasoning capabilities through a lot of RL. But importantly, they found that their pre-trained model had to be strong enough. So when they pre-trained these worse models, they found that the RL didn't lead to this like emergent reasoning capability as strongly as if you had taken these larger DeepSeek v3, like their largest version, and RL'd it instead and found much better performance. All of these results kind of suggest that if you can pre-train better models, you can unlock intelligence in all sorts of capacities and really solve all these downstream tasks in a much better manner. However, and maybe what the unpredictable thing is, who knows what's next for pre-training, like if you continue to scale up better pre-trained models. Even though it's really unpredictable what capabilities we get out of pre-training, the actual recipes we follow to continue pre-training better models have actually remained quite predictable over the history of the last 5 years of pre-training. So when you're pre-training a large model, perhaps the primary constraint in practice is that pre-training is really, really expensive. And there's usually some sort
Ad break. Ad break. For a full minute. Zoom out, zoom out. Since our regularized response. Oh. Loss following simple power law and parameter count. Okay. Best possible performance via what is that? Asymptote? Is it scaling law rather than the performance at a fixed compute budget? Uh-oh. We've officially entered a territory I have no idea of. It's cool. I feel like I have like 50% of ideas of what the words are happening here. Even though that sentence, most of it, I'm not sure. I mean, scaling law, I understand what it means. It's like getting more better things. Like more data, more compute. Rather than the performance at a fixed compute budget. Are we back? I think community is back. Okay, let me go back to the video. It's cool though, because most of the time I also don't have any idea what's happening. We either Google it and figure it out together, or someone in chat will know what's happening and help us, which is fine. Like, not everybody is an expert in everything.
Perhaps the primary constraint in practice is that pre-training is really, really expensive. And there's usually some sort of compute constraint that you care about. So people study.
Absolutely. Literally no one can do pre-training. That is, I feel like, I don't know if universities have, depends on the university and the research project, if they have the capacity to do pre-training. But like creating a model like ChatGPT, is difficult, but then building on that model is not difficult. And that's me trying to explain to a bit.
What is the best possible model you can pre-train subject to various compute constraints? And this, the study of this has resulted in these very predictable scaling recipes that predict how more compute can be spent to pre-train better models. The first example of this, maybe the most classical example of this, is train compute. So the question is, what is the best possible pre-trained model you can produce subject to a constraint on train compute? Maybe the work on this has settled in kind of this chinchilla scaling recipe, which suggests that for a fixed compute budget, you should not repeat any.
I don't know what's a chinchilla scaling, but I know what's a chinchilla. It's an animal.
Data, because you usually have more data.
I think I'm gonna Google that. Hold up. Let's look up the word chinchilla scaling. Oh, because it looks like a scaling on the back of a chinchilla. Proposed by DeepMind. When? Chinchilla scaling 2022. You streamed on the chinchilla. What? Uh-oh, are you telling me I'm forgetting everything that I've ever done? Well, here we go, guys. Compute training Training compute optimal large language models. But did I wait. Did I? First of all, what does a chinchilla look like? Is it the thing with the scales? Oh no, it's not. Huh. Then why are we calling it a chinchilla? Set of rules for optimizing large language models in a given compute budget. Okay. They suggest that. So they just named it chinchilla law for no reason. Or maybe it was in the Hugging Face stuff. I'm 90% sure it was a part of a lesson. Did it even have the name? State of the art average accuracy. MMLU. Something, you know what? Let's not go into too much detail. I will get lost. So it has to do with compute budget and cool. Originally the paper called the model trained. Called the model. Okay. Which is why, like, why is it called a chinchilla was my question.
Data than the available amount of budget. You should of this chinchilla scaling recipe, which suggests that for a fixed compute budget, you should not repeat any of your data because you usually have more data than the available amount of compute. And then you want to set the parameter count and token count in a 1-to-20 ratio. And as you increase the amount of compute that you have, you jointly scale up this parameter count and token count. And this is indicated by, on this plot, the different colors indicate different flop budgets. And you show that as you increase the total compute budget, you also increase the size of the models that you train. The other example of people caring about saving compute during pre-training is trying to save inference compute. So even if you minimize the amount of compute spent during training, this might produce a model that's really annoying to inference at test time because you have to keep inferencing this for all the users that want to use your model. The common recipe to handle this is to train these models on much larger token counts than is prescribed by Chinchilla. So even if it costs more train compute, it saves you inference compute in the future. As a canonical example of this, Llama.
Yes, inference does mean when you use a model. It's called inference. Yeah.
Which pre-trains a bunch of models, pre-trained Llama 8B, which is our most used model out of this. And this model is pre-trained on 15 trillion tokens. And this corresponds to, instead of a 1-to-20 ratio between parameter and token count, this corresponds to a 1-to-2000. So the models are 100 times smaller than what you would normally do in practice.
To lower inference costs with small models. Okay.
These are all a couple of different ways.
So cost, not time. Like how much it needs to use instead of like the user waiting.
In which people have studied how to train the best possible model subject to a compute constraint. And we built up a pretty good landscape of, if you had a finite amount of compute, what is the best possible model you could train if the amount of data you have is really not the bottleneck.
So chinchilla scaling laws ignored the compute spent outside of training. Okay. Using the models. Oh, what did I do?
However, the problem is that we are actually running out of pre-training data, and that pre-training data is growing very slowly. So Epoch AI.
Okay, I suppose we've already trained most of the models on what's available on the internet. We don't have anything new. Could be the point.
AI has these estimates of how fast the raw text on the internet is growing, and people are finding that the amount of text on the internet is growing at some slow 2 to 4% per year. Which
really, I feel like with the Gen AI, I feel like the internet is now full of slop.
Which indicates that the amount of text is not growing that rapidly. Beyond
maybe something like Common Crawl would figure this out more, right?
Beyond just text, there are many other domains where the amount of data we have is already really naturally limited. And for example, things like rare languages or things like biological domains, we don't actually have that much data over there. And we're already in this regime where we don't have that much data compared to the amount of compute that we have.
Absolutely true. Go ahead, continue. I'm not letting him speak. I have a feeling this AI thing is going to pop. Oh, the bubble? Well, I mean, the answer is yes, but how? Yeah. the web has been around for like 30 years. It makes sense. Year on year aren't. Yeah. Yeah, it's not exponential, basically. Yeah. I mean, even the number of users on the internet is not growing exponentially, so that would make sense. But still, when you hear like the number of videos uploaded on YouTube, like the hours per day or per minute, you'd still be like, wow, humans are interesting. And here I am contributing to it.
The core observation that we are going to be operating under this work is that even if the amount of data is growing very slowly, the amount of compute that people are willing to spend on pre-training has been increasing really rapidly, maybe around 4 to 5 times per year.
True.
If you take the simple composition of these two facts, you'll notice one very simple observation that the amount of compute we have per token is really increasing really rapidly. And we can't continue to follow these chinchilla scaling recipes that we've been following thus far. So even if the current practice tells us...
Oh yeah, the dot-com bubble. Absolutely. We still have websites, but it's not as much as it used to be, right? The stupid business stuff is going to go away, but the science is still interesting, I think, and will continue, though perhaps slower after it pops. Yes, I hope we don't get another AI winter, but I also am on the side of the base. I feel like it's the same with blockchain stuff. Like there's a strong base of science and everybody's like just saying, putting that keyword in stuff so that they get money. Same with AI. There is a base foundational science there. So it will continue rather slowly after it pops. So, but I feel like it's going to be, yeah. We'll probably get another fancy thing. Till we get there, it's still like people are, well, not people, but you know, like billions of money is being poured into it. So yeah, interesting though. Like we're going to see it most likely, you know.
How to use limited compute when given unlimited data. The actual regime that we care about is how should we use our compute when we're actually constrained by the amount of available data. And we operationalize this under a very simple question that allows us to really study the depths of this.
Some will call that slower progress, less investment, and AI winter. Yes, but Gen AI is not going away unless, like, we make it illegal. I doubt we would do that. What was it? Like I saw someone saying, oh yeah, okay. I think it was a comment under Hank Green's video. Not the one that came out today because I haven't seen that one, but recent one about aliens. Very hard to close Pandora's box. Exactly. Yeah, Gen AI is a Pandora's box. AI, everything. I don't like to use the word AI, but here I am using it. The comment was saying, even if aliens came to Earth, it's not going to be like the movies where we're all like together and trying to solve it. So me saying, trying to like make AI illegal, it's not possible because like so many different governments. Yeah, we'll see. Definitely not. I'm just saying it's really difficult to have humanity do one thing altogether. There we go.
This problem, which is how should one approach pre-training when constrained by data and completely unconstrained by compute? Maybe it's worth taking a second here to think about what you guys would do if you were given in this scenario yourselves. So one point to be made is that this regime of where the amount of compute you have exceeds the amount of data is not very different from ML a long time ago before modern pre-training. So for example, classic statistics is really often concerned with the task of like inferring parameters or models from a finite number of samples, kind of ignoring a notion of compute constraint often. And also classical benchmarks like MNIST and PenTreeBank often did implicitly have a lot more available compute than the amount of data that's available for the task.
Okay.
However, I guess there's a pretty different regime that we're living in right now, which is that people are really willing to spend a lot more compute to pre-train better models. And people are going to continue scaling this 4 to 5x compute. And they're willing to do this in a way that they weren't willing to grind out the last 0.1% of MNIST. It is a really
Yes, and I watched a recent OpenAI video. I got about 1 minute into the latest Hang video, and it's spoilers about who's that? Uh-oh. Uh-oh. No way. Oh my god, now I'm more excited to watch it. Oh, now I know. I know the guy, I just didn't remember his name. I mean, I've read his books, so I am to go back to my point. I watched up until the Q&A part. Actually, I watched a bit of the Q&A part as well because the questions were really like they picked all questions and not just the ones that sounded good to them. OpenAI video where Sam Altman is giving an update. I think it's from 2 days ago. It's actually a nice thing to watch, I suppose, because they're talking to the community. Whether they're doing a good job or not, that's a different story. But they were talking about 2028 as like a goal post for like doing scientific discovery. Gen AI for videos is truly dystopian. Absolutely. You can't believe your eyes. You know what, like one of the points from that video I saw wait, let me use my brain. Okay. One of the points I saw in that video was he was like, so this is what we've done until now, like humanity, in progress in science, and this is what we could do with AI. And that video was made by Sora. And I was like, come on, man. Like, I get it. Like, you could do something like Sora gave us these inspirations and we paid this many artists to build on that. You know, like, just try to not take money away from normal people. Anyway. And they were actually addressing the Sora 2 app about like ads and slops and all of that, but they didn't go into too much detail. Oh god, I need to learn how to pronounce this. Phosphoro? Okay. Is live, by the way. Yes, maybe we could raid and do this another time. That is what I'm thinking as well. I was like, I might do this for maybe another 5 minutes or less. Because I do have their channel open on tab, and let me use my brain. I will need to end the stream, but let me think. Oh, I was thinking of like a good place to pause this before doing that, and I was thinking either to like watch this at the end of tomorrow's stream, or like you said, on Discord, continue on Discord. I might do that, watch this tomorrow's and stream, end of the stream. Okay, let me play it for a bit and find a good place to pause. Maybe next slide changing.
Really important. They're willing to do this in a way that they weren't willing to grind out the last 0.1% of MNIST. It is a really important task to continue pre-training better models because it helps so much for so many downstream tasks.
Oh.
In this
and that's how. Yeah, no, definitely need to pause because I see the next slide is like 2 minutes long, almost 3 minutes long. So limited data, which they will cover in like 1 minute, will also means like low resource languages. I mean, they did cover that just a minute ago. We're at minute 8. If I go back in this picture, they're saying rare languages, which rare languages, sorry, I punched the mic, is different from low resource data, for sure. But like, if we're not being pedantic about it, they're similar-ish. Even the other document stuff. But yes. And I definitely want to continue learning about what they're saying. Like, I would probably normally listen to this in the background while doing other stuff. What would other stuff be? I don't know. Like, it's been a while since I've gone for a walk. Anyway, other stuff. So yeah, I think I'm gonna. So according to this, if I say ready, wait, there was a, where is it? Hold up, I'm supposed to do something. Like right now, I think that was supposed to be the thing. Yes, it's right now. So guys, if I say right now, we're going to go to their channel. So we're gonna say hi there. I would appreciate if you guys join me. If you don't have time, it's alright, but I would appreciate if you guys join me for as long as possible. And thank you for being here. I really appreciate that. 30-40 minutes in, they'll apply their learnings to small compute constraint training too. Awesome. We'll get there when we get there. So yeah, I am going to click right now and then end my stream because it's streaming on YouTube as well, you know. But Twitch side should be fine. So thank you for being here. See you next time, whenever that might be. And I'm glad I'm a part of this streamathon thingy. Yeah. So catch you next time. Kind of infinite computing back again. Huh? We'll get there. Okay. Bye from my side. Let's go and say hi to our next stream, which should be hopefully soon. Help. Do I rate it normally, or should this right now work? In the middle. Yes, that is the Middle Earth game. Exactly. I wrote right now. Oh, success. We'll be rating in a few seconds. Nice. And we're going. Are we there yet? I'm hoping we're there yet. Oh, oops. Are we there yet? Oh my god, what's happening? Wait, did we not go or did we go?